IIT JAM 2023, question number 16. Y is equal to yx be a solution curve to this differential equation. Now, what kind of a differential equation do I have? Dy by dx is equal to y by x ln y by x. So you can see that I have a y by x format. So this is differential equation with substitution. Okay. So what will I do? I'll basically do this. Y by x is equal to v. This. And then I convert it in terms of v and then I solve it. Okay. So let's go on the whiteboard because this can be a little lengthy. Okay, this is what we have. Y1 is equal to e square, y2 is equal to alpha. Find dy by dx. Okay, this is what we need to find. Okay, so first we need to solve this. Firstly, what do? Y by x is equal to v, or dy by dx is equal to v plus x dv dx. And this is basically v plus x dv dx is equal to v ln v. Okay, so this can be written as x dv dx, v common ln v minus 1 dv. Okay, now we take z is equal to ln v, so dz is equal to 1 by v dv. 1 by v dv is equal to dz, so this can be written as dz by z minus 1 is equal to ln x plus the constant. I can write it as ln c. Okay, this is my constant of integration, ln c, and this is basically ln z minus 1, which is nothing but ln of ln v minus 1. Okay, so this can be written as log v minus 1 is equal to log of x into c, because ln x plus ln c is ln x into c. So this is basically, if I take anti-log, ln v minus 1 is equal to cx. So ln v is equal to cx plus 1, or v is equal to e to the power of cx plus 1, or y by x is equal to e to the power cx plus 1. Y is equal to x into e to the power of cx plus 1. Y as a function of x can be written in this form. Okay, or you can simply remove y is equal to this. So what I did was I took y by x is equal to v, then I did this, then I wrote it in terms of v, then I wrote it in terms of y by x, and then this is what we get. Okay, we know that y1 is equal to e square. Put 1 here, 1 into e to the power of c plus 1 is equal to e square. C plus 1 is equal to 2, c is equal to 1. C is equal to 1, equation A. I found out the value of c. So y will be equal to, now y2 is equal to alpha, given, right? Yeah. So y2 is basically 2 into e to the power of 2 plus 1, which is 2 into e cube. That's equal to alpha. Okay. Now dy by dx at 2 comma alpha will be basically, alpha value I already know. So dy by dx at 2 alpha is equal to 3 e cube. Now alpha is equal to 2 e cube. Alpha by 2 is equal to e cube. Okay. So dy by dx at 2 alpha is 3 alpha by 2. What option is this? D.
Question number 17, IIT JAM 2023. Okay. So we are given 2z and we have to find out 2z raised to the power 8. So first we isolate z. Z will be 1 upon 2 minus 3 plus root 3i. So z square will be 1 upon 4 minus 3 plus root 3i whole square. So z square will be 1 upon 4, 9, 3i square, which is minus 3 minus 6 root 3i. So z square will be 1 by 4, 6 minus 6 root 3i, which will be 3 by 2, 1 minus root 3i. Again, we square, z4 will be 9 by 4, 1 plus 3i square, that is minus 3, minus 2 root 3i, which will be 9 by 4, minus 2 root 3i. So z4 will be minus 9 by 2, 1 plus root 3i. Again, we square, so z8 will be 81 over 4. 1 plus root 3i square will be again 3i square, which is minus 3, plus 2 root 3i, which will be 81 over 4 minus 2 plus 2 root 3i. Okay. So again, Z8, we take 2 common. So 81 over 4, 2 minus 1 plus root 3i. Okay. So now we cross multiply. 2Z8 will be 81 bracket minus 1 plus root 3i. So option B is the answer. IIT JAM 2023, question number 18. Let an be the nth term of the sequence, then which of the following is not correct? So we have to find the incorrect statement. Let us observe the general term of the sequence first. So let's try to find out whether this limit exists or not. Okay. So limit n tending to infinity an is limit n tending to infinity 1 upon 1 plus n. I can write this as n and whole raised to the power half. So we can write it as limit n tending to infinity 1 plus 1 upon n whole power n and raised to the power half. Now, for a sequence, if limit n tending to infinity an exists, okay, then the sequence an is convergent. Okay, so now this limit is the standard limit e. So e raised to the power half, which is root e. Now this is a finite number, so limit exists, so the sequence is convergent. Okay, now if a sequence is convergent, it is automatically bounded. Every convergent sequence has to be bounded. So this is a correct statement. So the statement A cannot be the answer. Now let us look at this statement. This statement. Okay, this is a very famous rule by Cauchy, which says if an is a convergent sequence, if an is a convergent sequence and the limit is n, then limit n tending to infinity 1 upon n a1 plus a2 till an, this limit goes to the same limit n. So if we see, this limit should be the same as the limit of the sequence an. Okay, so this limit actually is equal to root e, which is correct. So therefore this is a correct statement. Okay, now we will move to the next two options. Let us look at this option. An is increasing, so let's try to input some values for n. So a1 is 2 raised to the power half, which is root 2. Then a2 will be 1 plus 1 upon 2, that will be 3 upon 2, raised to the power 1, which is 3 by 2, which is 1.5. This is approximately 1.414. So we will notice the pattern that this sequence will keep on increasing. So yes, this is an increasing sequence. So this is a correct statement. So our answer should be this. For clarity, let's try to verify this. Okay, now we know that if at all this series an is convergent, if at all it converges, then this implies that limit n tending to infinity an should be 0. Okay, this is a standard rule. This is necessary condition for convergence of a series. Now in this series, this is my general term. Okay, so let us see what is the limit. If this limit does not go to 0, this series will not converge. Okay, now limit n tending to infinity ln of an will be limit n tending to infinity ln 1 plus 1 upon n by 2. So the power comes out, it is n by 2 ln 1 plus 1 by n. Okay, now this is limit n tending to infinity n by 2. Now we will use this series ln 1 plus x is x minus x square by 2 plus x cube by 3 and so on. Okay, so this is 1 plus 1 upon n. So this will be 1 upon n plus minus 1 upon 2 n square plus 1 upon 3 n cube and so on. So, you know, this n by 2 will get multiplied inside. So this will be 1 upon 2. Then this will be minus 1 upon 4n, n by 2 into 1 by 2 n square, that will be 1 by 4n. And similarly, we will be getting the n in the denominator. So if I multiply this, we are going to have 1 upon 6 n square and so on. Now, limit n tending to infinity of this series, okay, this expression, this will be half because these terms will go to 0 as n tends to infinity. So we can see that this, the general term of this series does not converge to 0. Okay, so therefore it is not a convergent series. So this is our answer. This is an incorrect statement. So which of the following is not correct? Answer C. IIT JAM 2023, question number 19. We have this linear programming problem where we have to minimize Z dependent on x1, x2, x3 subject to these constraints. So we can see that we have three variables. So we want to check which of the following condition is true. Okay. First of all, it is a problem in three variable. So let us try how its dual looks like. So this equation, this inequality is actually x1 plus 3x2 plus 0x3 greater than or equal to 3. And the second one is x1 plus 2 0x2 plus 2x3 greater than or equal to 5. Okay. So the dual should look like this. When we create the dual, we will have a maximization problem. We will be maximizing W. And then these are the coefficients 3W1 plus 5W2. W will depend on two variables. And now let's try to find out the constraints. My constraint will be 1W1. That means W1 plus 1W2 less than or equal to, because I have greater than or equal to. So in the dual, the inequality changes. So less than or equal to 4. Then the next is 3W1 plus 0W2 less than or equal to 6. Then 0W1 plus 2W2 less than or equal to 6. So this is actually W1 less than or equal to 2 and W2 less than or equal to 3. So this is my dual. And now if you see that my dual depends on W1 and W2, which is a two variable case, which can be easily solved using graphical method, corner point method. So let us try to draw the graph of these inequalities, how it will look like. We'll try to make a rough graph. So this is my W1 axis and this is my W2 axis. And now this is my point 0, 0, 0, 1, 2, 3, 4. I am going to make a rough figure 1, 2, 3, and 4. And now if I draw this line with equality sign, W1 plus W2 equals to 4, this will pass through 0, 4 and 4, 0. Okay. And then I have W1 less than or equal to 2. So I have a restriction here. This is my restriction, W1 less than or equal to 2. That means area towards the left side of it. And my second restriction is W2 is less than or equal to 3. So this is my restriction. Okay. So I am going to get 4 corners. Okay. This is 1 corner. This is 1 corner. This is 3, 4, 5. I actually got 5 corners. So suppose this is 0. This is A. This is B. This is C. And this is D. Now these are evident. This is 0, 0. This is 2, 0. And this is a 0, 3. This is going to be 2, 2. You can verify this line passes through 2, 2. And this is going to be 1, 3. Okay. So I've got my corners and this is my feasible region of the dual linear programming. Now we will see what is the maximum value, where the maximum value is going to occur. So we will check the value for W at each of these points. So at the point A, 2, 0, my W is going to be 6. At the point B, 2, 2, my W is going to be 3 times 2, 6 plus 5 times 2, 10, 16. At the point C, that is 1, 3, it is going to be 3 plus 15. So it is going to be 18. Okay. At the point D, 0, 3, it is going to be 15. And at the point O, W is going to be 0. So since my problem is the maximization problem, this is my answer. Okay. So basically, so W star, that means W star, which is the optimal solution, this is equal to 18. And W1 star, comma, W2 star, this is going to be 1 plus 1, 3. Okay. So this is my observation from the solution of the dual problem. Now we will eliminate options which are not correct from the given information. Okay. So now the information which we have is W1 star is equal to 1, W2 star equals to 3, and W star equals to 18. Always remember, the optimal solution of the dual problem is also the optimal solution of the primal problem, that is the original problem. So my optimal solution Z star is also equal to 18. And what is my Z star? My Z star will correspond to 4x1 star plus 6x2 star plus 6x3 star. This is equal to 18. This is the set of information I will be playing around with. Okay. So now let's see how to rule out these options. Let us look at the first option. X23 plus x3 dash equals to W1 star plus W2 star. Okay. So x2 star plus x3 star. Suppose this is true. Then W1 star plus W2 star 1 plus 3. That will be 4. Now we put in this equation x2 star plus x3 star. That it means 4 x1 star plus 6 times x2 star plus x3 star equals to 18. That means 4 x1 star plus 6. Now x2 star plus x3 star. Yes, x2 star plus x3 star is coming out to be 4. Okay. So 4x1 star plus 24 equals to 18. So 4x1 star equals to minus 6. That means x1 star is going to be negative, which is not correct because look at my condition. All these are supposed to be greater than or equal to 0. So the first option is ruled out. Okay. Again, let's look at the second option. Let's try to look at its possibility. Okay. So suppose this condition is true. Z star is equal to 4x1 star plus w star. So let us try to, okay, now my Z star is 18. So my 18 equals to 4x1 star plus w2 star. W2 star is 3. So we will have 18 equals to 4x1 star plus 12. So we have 4x1 star equals to 6 and we have x1 star equals to 3 by 2. So I am getting x1 star equals to 3 by 2. Now also let us try to solve this. Okay, so we have, now Z star can also be written down like this. 4x1 star plus 6x2 star plus 6x3 star now equals to 4x1 star plus 4 into w2 star, which is going to be 12. Okay, now this will cancel. So it means 6x2 star plus x3 star equals to 12. Okay, this means x2 star plus x3 star equals to 2. Okay, now we have these conditions. Let us see what contradiction we are going to get. So we have got x1 star. Let us look at this condition again. We have got x1 star equals to 3 by 2. Yes. And we have got 4 x1 star got cancelled from both the sides. So we got 6 x2 star plus x3 star equals to 12. So x2 star plus x3 star equals to 12. Now we have to start looking at what contradictions are we getting. Now we will have to look at these things. Okay. Which condition is actually not going to be satisfied. Let's see. Now suppose x2 star plus x3 star equals to 2. This means x1 star plus x3 okay star, and this means x1 star plus 2x3 star is greater than or equal to 5. Let us try to solve this first. So x1 star is 3 by 2. 2x3 star is greater than or equal to 5. So x3 star is greater than or equal to 5 minus 3 by 2. That is going to be 7 by 2. Yes. So x3 star is greater than or equal to 7 by 4. Okay. And now let us look at whether what this condition is going to give us. So 3 by 2 plus 3x2 star is greater than or equal to 3. So 3x2 star is greater than or equal to 3 by 2. So x2 star is greater than or equal to 3 by 4. So let us see whether we are getting any contradictions or not. I have got x2 star greater than or equal to 3 by 4. I have got x3 star greater than or equal to 7 by 4. Let us try to add them. So x2 star plus x3 star must be greater than or equal to 3 by 4 plus 7 by 4, greater than or equal to 10 by 4, which is equal to 5 by 2. So you see, my x2 star plus x3 star is greater than or equal to 5 by 2, which is a contradiction to this fact. Okay, so these two conditions cannot happen together. Therefore, this is also a contradiction. So we will have to work out with these conditions, and these conditions. So this is also a contradiction. So second option is also ruled out. Now we will look at the third option in the same way. So again, we will write what we have. We have w1 star equals to 1. We have w2 star equals to 3. We have z star equals to 18, which is equal to 4x1 star plus 6x2 star plus 6x3 star. So we will try to see what my condition C looks like. So we will start working with condition C. So let's look at condition C. Z star. So 6w1 star plus 6x3 star equals to z star. Okay. Now it means that 6w1 star, that means 6 times 1, 6 plus 6x3 star equals to 18. Okay. So this means 6x3 star equals to 12. This means x3 star equals to 2. So from here, I am going to get x3 star equals to 2. Again, if I am going to exploit this condition once again, so what is going to happen? Now I'm going to write the full equation. So I'm going to write 4x1 star plus 6x2 star plus 6x3 star equals to 6w1 star, which is 6 into 1, 6 plus 6 into x3 star. Let's see what we get. Okay, so we have 4x1 star plus 6x2 star equals to 6. So we have 2x1 star plus 3x2 star equals to 3. Okay, so this is my first condition. This is my second condition. Now let's try these conditions inside these inequalities and see what is going to happen. Now x3 star is 2. So x1 star plus 2x3 star should be greater than or equal to 5. It means x1 star plus 4 should be greater than or equal to 5. It means x1 should be greater than or equal to 1. Okay, this is what I'm getting from this inequality. Let's see. Now I have x1 plus 3x2 greater than or equal to 3, and I also have this thing. Great. So let us look at this. This is x1 star plus 3x2 star equals to 3. Now this thing is already greater than or equal to 3. Okay. So now this is greater than or equal to 3. It means x1 star plus 3x2 star should be, this should be greater than or equal to 3. Now this is also equal to 3. Now 3 greater than or equal to 3. Now that is only true when 3 equals to 3. Okay. So what exactly has happened is that this is equal to 3 and this has to be greater than or equal to 3. So we have to try to reach a distraction from here. Now you see my x1 star is greater than or equal to 1. My x1 star is greater than or equal to 1. Now let's see whether I reach a contradiction here or not. Okay. If this is greater than or equal to 3, okay. Now if this is equal to 3, x1 star will be 0, which will be a contradiction. If this is equal to 3, because this is greater than or equal to 3, this is equal to 3, x1 star will be 0, which is a contradiction. If it is greater than 3, then x1 star has to be negative, which is again a contradiction. So option C is ruled out. So option A wrong, option B wrong, option C wrong, and option D is correct. So option D is correct.
So this is IIT JAM 2023, question number 20. For alpha beta belong to R, consider the system of linear equations. So then what can be said? So there are multiple comments on the consistency of the equation, on the inconsistency of the equation, on infinitely many solutions, so on and so forth. So let's go ahead and understand when do we get what result. So let's put this on the whiteboard firstly. X plus y plus z is equal to 1. 3x plus y plus 2z is equal to 2. 5x plus alpha y plus beta z is equal to 3. Right? This is what we have as the information. Now, for equations to be consistent, this can be basically formed into the coefficient 1, 1, 1, 3, 1, 2, 5 alpha beta, x, y, z, and this is 1, 2, 3. Now, look at the first option. For every alpha is equal to beta, the equation is consistent. The system is consistent. Please understand, if I take alpha is equal to beta is equal to say 5. Why am I taking this? I'll tell you in a moment. So x plus y plus z is equal to 1. 5x plus 5y plus 5z, if I write, it will be the same as the first equation multiplied by 5. But the third equation gives me 5x plus 5y plus 5z is equal to 3. So if alpha is equal to beta is equal to 5, I can easily see that the first equation and the third equation are inconsistent to each other. If I take alpha is equal to beta is equal to 5, you can see that the first equation is x plus y plus z is equal to 1. And the third equation becomes 5x plus 5y plus 5z is equal to 3. But 5x plus 5y plus 5z should be equal to 5 if it has to be consistent with the first equation. Hence, for all alpha is equal to beta is equal to, for all alpha is equal to beta is equal to 5, this system of equation is inconsistent. So the first option, which says that for all alpha and beta, where alpha is equal to beta, the system is consistent, this is an incorrect statement. This is an incorrect statement. Therefore, for all alpha is equal to beta, the system is not necessarily consistent. So A is not the answer. Okay. So I hope that everyone has understood why A is not the answer. Now we'll go into the infinitely many solutions and unique solutions, so on and so forth. So if I name this as, say, the determinant value is delta. So delta not equal to 0, then only will I get a unique solution. If delta is equal to 0, I will either get infinite or I will get inconsistent. Okay, fair enough. So when is delta is equal to 0? 1, 3, 5, 1, 1 alpha, 1, 2 beta. I can simply expand by the first. Okay, 1 beta minus 2 alpha minus 1, 3 beta minus 10 plus 1, 3 alpha minus 5. This is equal to 0. This is equal to 0 will basically mean that the system does not have a unique solution. It's either infinite or inconsistent. So this is beta minus 2 alpha minus 3 beta plus 10 plus 3 alpha minus 5 So this alpha minus 2 beta plus 5 is equal to 0. So this alpha minus 2 beta plus 5 is equal to 0. If this happens, then either I have infinite solution or I have inconsistent equation. There exists alpha and beta satisfying this, for which the system has a unique solution. Incorrect. If alpha minus 2 beta plus 5 is equal to 0, then I will always have either infinite or inconsistent. I will not have a unique solution. The unique solution will happen if this is not equal to 0. So A and B are both incorrect. A and B is not the answer. Okay. Now we see about infinitely many solutions. Both C and D are saying we need to find out the pair alpha beta such that I have infinitely many solutions. So infinitely many solutions will happen if delta is equal to 0, delta x should be equal to 0, delta y should be equal to 0, and delta z should be equal to 0. So delta x is basically 1, 2, 3, 1, 1 alpha, 1, 2 beta. Again, I basically expand beta minus 2 alpha minus 1, 2 beta minus 6 plus 1, 2 alpha minus 3. Okay. And I already know beta alpha minus 2 beta plus 5 is equal to 0. So let's just put it there. Cancels out. When is this equal to 0? This is minus beta. So beta goes on the other side. Beta is equal to 3. So when beta is equal to 3, then delta x is equal to 0. Delta y is basically 1, 3, 5. 1, 2, 3, 1, 2. This is equal to 0. Again, expand it. 2 beta minus 6 minus 1 into 3 beta minus 10 plus 1, 9 minus 10. 2 beta minus 6 minus 3 beta plus 10 minus 1. This again gives me 3. Yes, this again gives me beta is equal to 3. So when beta is equal to 3, delta x is equal to 0, delta y is equal to 0. Now delta z, I'm basically taking a look at the conditions when I have infinitely many solutions. 1, 1 alpha, sorry. When is this equal to 0? 3 minus 2 alpha minus 1, 9 minus 10 plus 1, 3 alpha minus 5. 2 alpha plus 1 plus 3 alpha minus 5. Basically alpha is equal to 1. So when alpha is equal to 1, delta z is equal to 0. So alpha is equal to 1, beta is equal to 3. Put this in, alpha minus 2 beta plus 5 is equal to 0. Is it satisfying? 1 minus 6 plus 5. Yes, it is equal to 0. So alpha is equal to 1 alpha is equal to 1, beta is equal to 3 will also satisfy delta is equal to 0. So therefore, alpha is equal to 1, beta is equal to 3 will imply delta, delta x, delta y, delta z are all equal to 0, which will imply that for this value, I will have infinitely many solutions. So if alpha is equal to 1 and beta is equal to 3, I will get infinitely many solutions. Otherwise, I will get inconsistent equation if alpha minus 2 beta plus 5 is equal to 0 and alpha is not 1 and beta is not 3, then I will get inconsistent equation. Okay. And as a result, what will happen is I get my answer. So what do I get? There exists a unique pair alpha beta for which the system has infinitely many solutions. This is correct. For every alpha beta alpha not equal to beta, the system has infinitely many solutions. No. No. If alpha is equal to 1 and beta is equal to 3, then only will I get. Okay. For any other, like for example, alpha minus 2 beta plus 5. Okay. So alpha is equal to 2 beta minus 5. Okay. Now if beta is equal to say 1, alpha is equal to, say beta is equal to 4, then alpha is equal to 3. So alpha is equal to 3, beta is equal to 4, supposing. Alpha is equal to 3, beta is equal to 4 will mean that delta is equal to 0, but delta x, delta y, delta z are all not equal to 0. That is, my delta i's are all not equal to 0. So alpha is equal to 3, beta is equal to 4 will mean inconsistent equation. So for every alpha beta where alpha not equal to beta, satisfying this, the system has infinitely many solutions. No, no. Alpha is equal to 3, beta is equal to 4. If I get this is satisfying this equation. but it has inconsistent solutions. So A, B, and D are incorrect. The answer is C. It's a very good question which tests your entire knowledge on how to solve a system of equation by the matrix or the determinant method. Answer is C.
Exam 2023, question number 21. For a positively sloped LM curve, which of the following statements is correct? A decrease in the price levels, this shifts the LM curve to the right, so this is incorrect. A lower nominal money supply, this shifts the LM curve to the left, so this is incorrect. An increase in the price level, this shifts the LM curve to the left, so this is again incorrect. A higher nominal money supply, will shift the LM curve to the right, so D is correct. Question 22. So this is an economy with 2010, 11 and 12 prices and quantities of apples and bananas. We have to find what happens to the GDP deflator for 2011 and what's the inflation rate for 2011. So let's first find out the GDP deflator for 2011. So the formula for GDP deflator is, it is the nominal GDP divided by the real GDP into 100. So let's find out the nominal GDP for 2011. So that's going to be 1 into 200 plus 2 into 100. So 200 plus 200, that's going to be 400. That's the nominal GDP for 2011. Now what's the real GDP for 2011? So taking 2010 as the base, it's going to be 200 into 1 plus 100 into 2. That's again 400. So both the real and the nominal GDPs are the same because there has been no increase in prices. So the deflator is 100%. And there is no inflation. So the GDP deflator for 2011 is going to be the same as the deflator for 2010, which is 100. The base year is always 100. And the inflation rate is 0%. So the answer is A. Question 23, which of the following statements is not correct in the context of an open economy ISLM under floating exchange rate? So let's see, this is IS and this is LM. And let's remember that the question is which of the following is not correct. Okay, so this is R is equal to R star. This is PCM, perfect capital mobility. We have interest rate here and we have output here. All right. Now, an expansionary fiscal policy would appreciate the domestic currency value. So if IS would shift out, then R would go above R star. And that would attract capital. So there would be capital inflows. And that would lead to currency appreciation. So this is correct. A is correct, but we actually have to mark not correct. So this is not the right answer. An expansionary monetary policy would depreciate the currency. So if it is an expansionary monetary policy, R is going to be less than R star, and it is going to have, capital is going to move out and it is going to depreciate the currency. So even this is correct. So this is also not the right answer. Exchange rate has significant impact on determining the equilibrium level of income and employment. This is, monetary policy is fully effective in determining income and employment, whereas fiscal policy is ineffective. So if, in case of an expansionary monetary policy, the LM shifts out, R is less than R star. If R is less than R star, there will be capital outflows, exchange rate would depreciate. If exchange rate depreciates, the IS shifts out and it comes back to the original equilibrium. So this is also correct that the monetary policy is fully effective, whereas fiscal policy is ineffective. So the entire line is correct. So if it is correct, then this cannot be the right answer. So exchange rate has significant impact on determining equilibrium level of income and employment. We will have to mark this as the only option, which is incorrect in that case. So if this is incorrect, then C becomes the right answer. 4. Which of the following statements are correct? Structural unemployment arises in between jobs. The first job which an individual has quit in order to find the second job. Frictional unemployment arises due to mismatch of vacancies and skills of individuals. So I think this is reversed. That is structural unemployment, mismatch of skills and vacancies. And this is fictional when a person has quit one job but still not found another job. So it's neither S1 nor S2. These are the definitions of fiscal revenue and primary deficit, and we have to match them. The difference between government revenue expenditure and revenue receipt is revenue deficit. Difference between government total expenditure and government total non-debt receipts minus interest payments, that is primary deficit. And difference between government total expenditure and government total non-debt receipts is fiscal deficit. So that is going to be A3, B1 and C2. So the answer is B.